right. Well, thank you very much, Simon, and to the folks in the library and the Calgary RSC for putting us together tonight. I'm kicking it off with a bit of a Milky Way tour. It's sort of using pictures I've taken over the last year or two or so, and just going to show you along the Milky Way. I'm going to get into the real technical aspects of how to shoot all these pictures. That could take all night on itself, but just to show you what you can see and photograph along the Milky Way, which we have above us now if we get clear nights in the next couple of weeks, and using techniques like these. So all the pictures I've taken tonight will show you tonight. We're taken with one of these three techniques: just a camera on a tripod, equipment you already have, perhaps a camera on a tracker, the center here, where the camera is now following the stars over the several minutes of each exposure, so the stars don't trail. And I'll point out a few of those pictures. And then the third technique that I'll show pictures from are with a camera through a telescope, now on a specialized equatorial mount, maybe guiding, things like that, more sophisticated to really get in-your-face close-ups of some of the nebulas and things I'll be showing you. Just to mention the kinds of exposures, because people always want to know, what exposure did you use, what ISO? Used to be, what film did you use in the old days? For cameras on a tracker, it's basically exposures of 20 to 40 seconds, at least what I'm showing you tonight. Wide fast lens f2 to f2.8 and pretty high ISO 1600 to 6400 with your stock standard DSLR or now mirrorless camera. When you're on a tracker like this, you can go longer, 1 to 4 minutes, probably as long as you need to go. f2.8 to f4, a little slower, stop the lens down, a little sharper images, and maybe a little slower ISO 800 to 1600. To get a little less noisy an image, because you can afford to go a little longer and slower because you're now tracking the stars. And through a telescope, telescopes are generally slower. A good fast scope still might be f4 to f6, like this instrument here is f5, actually, the little red cat telescope. Exposures are there for longer, 4 to several minutes, 10 minutes. ISO speed still reasonably high, but not overly so. For shots through a telescope where you're now tracking over several minutes time. So I'm going to show you pictures from all that regime of equipment tonight. But first of all, let me just go through the seasons. Coming up, well, kind of officially next month, but certainly when we get into April and May, we do not have the Milky Way above us. It's the season. Spring is always the season of the year when we don't have the Milky Way very well visible. The next series of shots are fisheye images. The Milky Way's there in springtime, but low across the north at all times. And because in springtime, we're looking out of, if we imagine our galaxy as kind of a flat disk, in springtime, we're looking out the top of the galaxy towards the North Galactic Pole, high in the south on spring nights, below the Big Dipper. There's the Big Dipper there. And so we don't really have the Milky Way. It's a great season for seeing and photographing galaxies, but not our galaxy, which is what the Milky Way is. Here in this picture, just kind of very dim here, is another phenomena in our solar system called the Gegen Shine, which is a glow of sunlight reflected off dust, interplanetary dust, beyond the Earth's orbit. Now here, now we get into July and August, the summer Milky Way. It's fantastic. That's the best Milky Way season of the year, in summertime and early autumn. And this is the Milky Way at its finest from Alberta, at one of the darkest spots in Alberta, if not Canada, Red Rock Canyon in Waterton Lakes National Park. And here's the Milky Way all the way across the sky. And the galactic center, now we're looking towards the center of the galaxy. It's low in the south in the summertime, but nevertheless, that's the brightest, most spectacular part of the Milky Way. And now the Gegen Shine, from such a dark site on a moonless night, really shows up. You can see it with your eye, but cameras really pick up that faint glow. And that's, again, interplanetary dust in our solar system. Now we get into autumn, into September, October, and November. The Milky Way is across the sky all night long. We do really get a good view of the Milky Way. The galactic center is disappearing from sight. It's below the southwest horizon. We've lost the brightest part of the Milky Way, but we have a great view all along the summer and autumn and into the winter Milky Way. When I took this picture 2 years ago, Mars was bright in the south. That's the bright red object there. And this night, Orion is stay up late enough, but not too late. Once you get into late autumn, Orion is becoming visible, signaling the start of the winter season and the winter Milky Way. So here's our winter Milky Way. This is, if we get clear nights in the next 2 weeks, this is the sky that'll be above us as it gets dark in the next 2 weeks, with Orion due south in the sky and the Milky Way all the way across the sky, not as bright as it is in summer. But the next 2 weeks, with the moon now out of the way, it was full moon last night, are going to be the best season for seeing the zodiacal light, this faint glow again of interplanetary dust. But this time it's kind of close in the evening sky, low in the southwest in the evening sky, or across the southwest. So the next couple of weeks, last 2 weeks of February, will be a great time for seeing the zodiacal light and photographing it. Now, we're in this galaxy called the Milky Way. We are here in the outskirts, about halfway from the center to the edge. In the wintertime, we look towards the outer edge of the Milky Way. So there's not as much stuff between us and the depths of intergalactic space. So the winter Milky Way is not as bright and as prominent. That's the direction towards Orion. But in the summertime, we're looking towards Sagittarius and Scorpius, towards the rich center of the galaxy. So the summer Milky Way is a lot brighter. Well, let's start with a little tour here through the sky that's above us right now. In the wintertime here in February, prime time to see and photograph Orion. High in the south, below it is Sirius, the brightest star in the night sky, and above it, the Pleiades star cluster, and Cassiopeia way high above us in the wintertime, especially in the autumn sky. So this is the prime time to see Orion and enjoy its sights. It's a beautiful constellation, all kinds of great things to look at with binoculars, small telescope, any telescope, or to photograph. And this is a shot with a 50mm lens on a tracker for a few minutes. And you start to pick up these faint nebulas that you, in some cases, you cannot see with your eye at all. And the famous belt of Orion, the 3 stars in a row, the belt of Orion, that's so distinctive. And then the fuzzy sword, you can see it has a fuzzy star in it. That's the Orion Nebula. That's this object. Now, this is a long exposure taken with a very fast telescope made for astrophotography, really picking up the faint dust clouds and interstellar gas. But even through binoculars or a small telescope, you can see that bright core of the Orion Nebula. It's a bright greenish glowing cloud. That's the Orion Nebula, known as Messier 42. And then above it is a fainter nebula called the Running Man Nebula. Perhaps you can see the figure there of the Running Man, and a beautiful area for photography. And this is now through a telescope. Going back to a wider angle shot through a tracked piggyback lens, 50mm lens, or maybe this is a 28 or so. Above Orion, we have the bright Pleiades star cluster, another great photogenic object, and the wider, bigger Hyades star cluster. Both beautiful binocular objects. And you can see a lot of these faint reddish nebulas as well, which can be tough to see, but easy to photograph. And then you also have, you can see these to the naked eye from a really dark site on a winter night, moonless winter night, these Taurus dark clouds, dark interstellar dust that's close to us in our galaxy and that's hiding, obscuring more distant stars behind. So let's go to the Taurus dark clouds, quite large, stretch over a good portion of the constellation of Taurus up into Perseus. But by the time we get into April, and I shot this from Dinosaur Park last April, the last of the winter sky setting into the evening twilight, the Pleiades star cluster there disappearing. There's the Hyades, Orion, the belt of Orion, and Sirius all setting. We're saying goodbye to the winter sky, not too soon perhaps, and as we get into the spring season. But once we get into late April and certainly into May and June, now we're at prime season for seeing the summer Milky Way rising as an arch across the sky. It's not yet overhead. This is the best season in spring to get a panorama, as I show here, of the arc of the Milky Way, this Milky Way Arch. This is a panorama of several pictures taken at 20 or 30 degrees apart, turn the camera, turn the camera, turn the camera, and then stitch them together in Photoshop. So this is a panorama of many shots, but you can see this with your eye as this arch. That's the summer Milky Way rising. Now, this was, again, a May shot, I think, from last year. Now, this is a very single shot, but a very wide angle shot, an 11 millimeter fisheye lens of, once again, the whole sweep of the Milky Way, the center of the galaxy rising at right, and then up into the summer Milky Way and an aurora. That's what I was really shooting that night, the aurora, with an unusual aspect of the aurora called a SAR, stable auroral red arc. That's another thing kind of related to Steve that Chris will probably be talking about. So this was a kind of a bonus here to catch that along with the Milky Way. Once we get into the summer season, and I shot this last June, early June, when we had a dark of the moon period from Waterton Lakes, from Maskinong Pond. Now we get the galactic center due south, that brilliant star clouds, the brightest part of the Milky Way. Beautiful to see and wonderful to shoot. And so this is early June, where from that latitude, a couple of degrees further south, the sky's just that much, a little bit darker, even around the summer solstice time. We're getting the June here. And here's one of the signature areas of that part of the Milky Way, the galactic dark horse, made of more of these dark dust clouds in the shape of a dark horse prancing in the Milky Way. And you can see that with the naked eye. The Lagoon Nebula, very bright and red in photographs. And this massive, bright Sagittarius star cloud, it's marvelous to look at with binoculars. And then above it, the small Sagittarius cloud, also a wonderful sight, just in binoculars of low power and a telescope. And the bright yellow orange star Antares and Scorpius with all kinds of colorful nebulosity around it. That's a favorite of astrophotographers. And here it is again, taken the next night, went out to Cameron Lake. The road opened up for the first time this year or last year in Waterton Lakes. And so this is that area, same area of the sky over the mountains at the south end, actually in Montana, of Cameron Lake, the extreme southwest corner of Alberta. And this one and the previous shot are blends of the sky taken with the tracker, and then turn the tracker motor off, and then the horizon, the landscape taken without the tracker motion to prevent it from blurring. So that's a blend of tracked and untracked shots. And there's the galactic center, low in the south, even from right down at the border at 49 degrees, Antares, that yellow giant star in Scorpius, and the Lagoon Nebula. Beautiful area of the sky. And Waterton, I love Waterton, to be going down there again this year, I'm sure. This was July, this was early July, where the sky is still not technically pitch black, astronomically dark, but from Waterton, still very good in early July from Driftwood Beach with that beautiful galactic center over Middle Waterton Lake there. Now, as we get later into the summer, we got the whole Milky Way coming up all across the sky and above us, Sagittarius low in the south, Cygnus now overhead. And we get into the constellation of Cygnus, a beautiful area to explore with binoculars and just a tracker, 50 millimeter lens, picking up all kinds of this faint red nebulosity, the North American Nebula that you can see with the naked eye, but the colors come out with the exposures on the cameras. That's the beauty of astrophotography. The camera picks up the colors. This dark funnel cloud nebula, that's obvious to the naked eye from a dark site. The funnel cloud nebula, the butterfly nebula in central Cygnus, that's a tough subject to see through a telescope, but easy to pick up with the camera. Same with the Veil Nebula, the remains of a star that exploded 10, 20, 50,000 years ago, whatever it is. The Veil Nebula, beautiful photographic object. Moving along the Milky Way, we get to the W of Cassiopeia, the Queen, the 5 stars in the W shape. Another area rich in this nebulosity that shows up in photographs, the Heart and Soul Nebulas. And these guys here, which only have the catalog numbers up in the autumn sky. Now moving into the autumn Milky Way. And the Pac-Man Nebula, because it looks like the old Pac-Man figure. What the astronomers a century or now will think of that name as, I don't know. But anyway, that's the Pac-Man Nebula. And then last October, I had a fabulous clear night from my backyard. I live out in the country near Gleason. And so I shot a panorama along the Milky Way with the tracker, but just moving the camera along the Milky Way and taking several shots and stitching them together. And that shows you Cygnus and Cepheus and Cassiopeia and Perseus and Auriga all along the richest part of the Milky Way, high overhead in the autumn season. And then over the last couple of years, I've been taking pictures with all the latest camera gear and telescopes and whatnot I've been testing and owning and buying, and use that montage, that mosaic as the background for a montage of images I've taken with telescopes, like the one I showed you at the beginning, the little red cat telescope, and other telescopes, of close-ups of all those nebulosity, areas of nebulosity in the Milky Way. Very rich field. You can be busy for years shooting all this kind of objects. But once we get into October, September and October, the Milky Way, the summer Milky Way is going down. We're saying goodbye to it. This was a beautiful night last September, I think it was, in Dinosaur Park. Timed it so the moon was just coming up, lighting up the landscape, but the Milky Way disappearing into the southwest. This was, again, last September from a favorite location around here, Elbow Falls, southwest of Calgary, with that last of the summer Milky Way disappearing and the moon just lighting up the landscape. And then in the autumn, stay up late enough, and by morning, here comes Orion again. And here's the winter Milky Way coming up when we're starting the cycle all over again. So it's that's our little tour along the winter and the summer and the autumn Milky Way with photographs I've taken over the last couple of years. That's my website if you'd like to see more. So that's my contribution this evening. Hope you enjoyed that. We'll take Q&A right at the very end of everything. I'm now going to turn it over to Siv, who's going to show us some marvelous, marvelous images she's taken of nightscapes in the Aurora. So I'll turn it over to Siv at this point.
Okay, so I'm going to start with my media shower. It's a Perseid media shower. That's one of the things that inspired me to the astrophotography. It's when after I witnessed the media shower at 2014 on a Germany media shower. That's how I started to wonder how to chasing the shooting star. And this one is in the Drumhaller on the Perseid media shower. And this one is in Waterton. And this one, it had to be in Cypress Hill, because around Calgary, we all have cloudy. So I have to do a little bit of driving to find some clear sky. And this one is a Gemini 2018 on Kananaskis. And this one is a fireball. That's is a lucky shot that I got it in a vertical frame and had to be picture on a 7 image to stick it together to get this panorama. It's just like a big one, biggest one that I ever got. And this one is happened on 2018 while I tried to shooting the Comet. And I got this one just like around 5 a.m. It's just like very, very big one. It's just shooting and lifting the contour like for about half an hour for that. And this one is one of my favorite waterfall. It's only 5-minute walk to that waterfall, but like 9-hour drive to get it there. So we got the moon bow. Like I have to do a lot of calculation for this one, try to get the moon set just on close to the horizon to bright up the waterfall with the moon bow while the visible with the Milky Way over top of the canyon. So it's like have to be on the right time. I tried it the second time, but it wasn't work because it's cloud. And this one is just my first picture from my first camera, just after I joined the Alberta Aurora Chase group And that's how I learned how to shooting all my Aurora and Milky Way from the group, from a lot of photographers that they will teach you and give you some advice how to do the setting. Alan Dyer has already show you some of the setting already. But for me, I just like go through with all my picture just to bring you. This one is a G3 Aurora looking east. That's one of the night that we remember about that. It's just in X-Hall. And this one is my first Steve. And this one is one of my favorite hiking, backpacking solo trip. Just do it by myself. It's 4 nights and 5 days. At the first night I got the Aurora, so just stay out and taking picture all night. And wake up, just start do a hike in the morning again, and wait until sunset, start again if I have clear sky. And it's so lucky that I got like, it's all 4 nights clear sky. That means I 4 nights have no sleep and just keep hiking and shooting at night all night until like, just get tired maybe 4 or 5 a.m. and sleep until 10 because I had to pack up before 11 and then keep continue. This one is like in a Berg Lake. So it's about 21 kilometer hike. I had to carry all those stuff, 2 camera, 2 tripod, maybe 4 lenses. But it's voted to do that. We found Steve in the back country. That is pretty cool. Just the Berg Lake with the heart shape on Mount Robson. And this one is another night that we have everything in this picture. We have neo-white comet, plus the noctilucent cloud and the Aurora. It's in Kananaskis. And Steve showed up that night too. So, but the noctilucent cloud kind of washed out because of the Aurora. And this one, it just happened on November 3rd and 4th. It's a pretty strong one from last year. And we met a couple of people from the Aurora Chase group. We don't really know each other, but when we met, we have the Aurora connect us together. And so we just see it all night. We've been like taking picture all night from 8 o'clock to 12 o'clock, like with the Aurora behind the cloud, but we never gave up yet. So around 12:30, the clouds start to clear up a little bit. And around 1:30, we got all this stuff. It's just all over the place. That's fit with the fisheye. It's like cover the whole thing. And I was shooting until like 3:30 that night. So I bring my neighbor with me. She's 73 years old. So it's time for her to go to bed, I guess. So I had to take her home. So we decided to leave around 3:30. And then after I drop her home, Aurora still there. So I just go to the lookout at the downtown and continue shooting until I think it's like maybe 5 to 7:30 until like the blue hour, almost sunrise. And then just go home and take like 2 hours sleep and then go to work. So it's pretty much more than almost 12 hours. Pretty much, you ever chase it until like the Aurora's gone, I guess. So the other thing that I do is the Milky Way. It's not hard. It's just wait for the cloud. If the cloud's gone, no moon, we can see Milky Way for sure. It's not hard to predict like the meteor shower or the Aurora either. It just need a clear sky and no moon. I was in Cancun for this one. It's so bright out because of the hotel, shine up all my foreground. So it's not hard to do anything with this picture. You got the Milky Way high up on the sky, and then the foreground already brightened up. I don't need any flashlight or anything. It's just perfect though. But I have to do some homework, like try to pick a hotel that have no light pollution around it. it's very good. It's almost close to the edge of the beach. Like we have a private beach there. So everything's pretty good. And this one is in Hagen, in Cuba. It's between two big hotels that have ponds here that we have away from the light pollution from the hotel. So I can get a pretty dark sky here. So it's a little bit blurry because of the heat, like the humidity. We don't have it here. In here, we have like freezing the land. So a little bit different, just hot and cold, different one. And this one in Jamaica. This picture like 2016 when I just started shooting the Milky Way. My first time edited this picture is worse than this much. It's way over edited, I guess, but my setting was pretty good. So I just had to re-edit it and then it was like very good. And my favorite place to shoot is a Hoodoo. That is my social media, Hoodoo 84. That's what I like. That's what the Hoodoo coming from. It's one of my favorite things to chase, like the Hoodoo and the Milky Way, I guess. And this one is my favorite dead tree in Burmese tree. It's like 2 hours from Calgary. It's way south. It's very good that you get for the Milky Way. And last year I've been went to this location almost 6 times in June, just to chasing the firefly. You see all that light, yellow light that flashing around. Every time I had to try to find it perfect, like no moon at all, because the firefly is gonna have more light on it. So just the star trail here to make sure that you can see all the trail from that firefly. I really don't know that we can get the firefly in Calgary. It's not from Calgary, it's just like east of Airdrie. And I hope I get more from this year. And if I was so tired from chasing my Aurora the next couple nights together, I can shoot it from my house. Anything with KP5 and higher, I can see it from my window for sure. But this picture, it was perfect because all the house is just no light at all. But right now, like this 2 year, most of the house, they have all the sensor. So it's really pissed me. Everybody prevent something. Most of them all have sensor on the backyard. So it's ruined my night sky a little bit about that. But at one time I used to try to stand on my roof on my garage, try to capture deer and just set my camera all night and go back to sleep and wake up, get my camera and go to work. If I have no choice, I guess. If I have choice and still have more energy, I can do it for sure somewhere near my house. But if no choice, maybe just shoot it from my window. So right here, it's on actually it's on October 14. That's when it's Thanksgiving. That's the night that I met Chris Ratzlaff. We've been knowing each other for a long time since we're doing the Steve documentary, but we never really go out shooting together. But it's just a coincidence that that night we met each other and I just recognized his voice. So are you a Chris Ratzlaff? And I say, yes, I am. So next I'm gonna let you meet Chris Ratzlaff.
Yeah, that was a perfect segue. That was a great night bumping into you, Siv. It was almost surreal because we were out shooting and we were standing beside each other probably for about 10 minutes. And you recognized my voice, and that was, it was quite bizarre. And one of these days I'm gonna have to figure out where your firefly spot is, because that's really cool to something I've been wanting to photograph for a while. Thank you to the Royal Astronomy Society Canada Calgary office for inviting me to speak. Thank you to the Calgary Public Library for hosting this. And I also want to note that I'm really glad that both Alan and Siv focused on the Milky Way, because I hardly touch on it. And even better for Alan to have been sharing all of his camera settings, because then we don't have to talk about my own camera settings. Alan has covered that quite nicely. For my talk tonight, I'm going to be focusing on timeline of my experience through Aurora chasing. And a lot of it's going to be almost all about Aurora, but we'll touch on a few other things as well. In the middle of the night, come across a bunch of different things that you don't always expect, and we're going to see a couple of what really scattered throughout the presentation. There'll be a few things that that catch you off guard sometimes in the middle of the night. But I'd like to start off with one of my very favorite photos. This is my first Aurora photo ever. It was the first time that it's not the first time I'd seen the Aurora, but it was the first time that I had a camera that I could actually take out and point at the Aurora and get a decent photo. The camera was not what one normally thinks of shooting with the Aurora. This was a point and click digital camera. I didn't have a tripod. I just rested it on its back, had it pointed straight up. I was able to take a 30-second exposure and get a decent photo of the Aurora from within Airdrie's city limits. You can see my garage there in the foreground lighting up, being very brightly lit, but I don't even know how strong the Aurora was this evening. It was back in 2008. One of the things that we tend to get annoyed with as photographers, or easily as Aurora photographers, is the moon. People tend to blame the moon for washing out the Aurora all the time. But the moon is really amazing for also lighting up your foreground. This is not a great photo, but what it really highlights, this is a full moon evening on a KP5 Aurora night. And you can clearly see the Aurora. The moon is really lighting up that foreground and kind of highlighting how the curve in the road and the curve in the Aurora are complementing each other. Not long after this night, this was in 2014, I think, we had another really strong Aurora night, where this was probably the first time I had seen a very strong Aurora. And the first time I had seen the reds showing up. This was out at place we call Twisty Road Pond, an area northwest of Airdrie, about maybe 30-minute drive from Airdrie, a 45-minute drive from Calgary. It's a very popular spot for Aurora chasers. Great location. The road, by its name, twists around a nice pond, and you can always find a spot around that pond where you can get a really nice photograph of the Aurora reflecting off the pond surface. There'll be a few other photos of it here as well, in the presentation as well. But on this particular night, it was really snowy. It was really cold. It was like minus 25 outside. And as I was pulling up around the pond, the snow was very deep and it was level with the road. So there was a pretty steep ditch. And in the top left, while I was photographing the Aurora, my truck was sitting here stuck in the ditch at about a 15-degree angle, slowly slipping down toward the pond, which was fortunately frozen at that time. But this is 2 a.m. Cellular reception in that location isn't great. And so I sent out a note to the Alberta Aurora Chasers community, said, I'm stuck. And at 2 a.m., two sets of people came out to rescue me. After taking some time to take some more pictures of the Aurora, they said, we'll be right there, but you know, there's pillars in the sky right now, so we'll be a little bit late. But both of these groups, Braden Moroso, Felix Lee, and Oren Sue, they both drove for about 45 minutes to get to this spot to help pull me out of the ditch. Minus 25, 2 in the morning. It was pretty awesome. This is one of my first favorite moments of the Aurora Chasers community, and in really being able to see what the community can do for each other. Here's a much more relaxed and casual evening at Twisty Road, at the pond at Twisty Road. This was in the spring. One of the things that I love about Aurora in southern Alberta is that we can take photos of the Aurora all year round. We aren't stuck in the winter. While the Aurora hotspots around the planet, Alaska, Yellowknife, Churchill, and Iceland, you can only take Aurora photos up there in the winter while they still have dark skies in the evening. But in the summer, the skies get so bright that Aurora doesn't show up as easily. Whereas in Alberta, we can see the Aurora all year round, so we can all be taking pictures without having to wear parkas. We can be wearing t-shirts, shorts. You don't have to worry about freezing, but you do tend to have to worry about mosquitoes, because a location like this, the mosquitoes love it as much as we do. This evening was, I had spent the entire evening up at a very dark location west of Didsbury. Well, actually even more west of Red Deer. And we'd only seen very quiet Aurora through the course of the evening. Nothing terribly much interesting. Had packed it up, started heading home, and then in the rearview mirror, I saw the Aurora starting to light up. So I got off the road, found a quick little spot with a nice little tree in the foreground, and managed to take a lot of photos of the Aurora as it was moving across the sky from west to east. And even a little bit later in that night, I relocated off to a nice little fishing pond east of Didsbury, sorry, and was able to catch probably one of my second favorite nights of the red auroras as they were dancing over the southern Alberta skies. You've got in the foreground of this photograph, the other interesting thing, as aurora photographers, we tend to not like urban lights. But in this case, that is, I believe, Red Deer glowing on the horizon against the clouds in the foreground, below the aurora, which is way up above the cloud layer. It introduces a nice element of scale and perspective, really showing you how high the aurora is above that cloud. This is another one of my favorite locations, this pond. I am at this spot quite a lot. It's about 45 minutes north of Airdrie, about 15 minutes east of Didsbury. This is another photograph from that pond. Probably one of my favorite composition photos. This wasn't a very strong night. At this point, it was the aurora was about KP3, a strong KP3. It did get stronger later in the evening, but with the aurora really low on the sky and reflecting off the pond, you get this really nice like Rorschach kind of art that was going on all evening, and there's all sorts of shapes that the aurora was creating between the pond and the sky, and framing the trees in the background there quite really nicely. Sometimes though, when we're out chasing the aurora, or when you're out in the middle of the night and you're all alone, you hear a lot of things. Everything you hear is amplified. Everything is louder. Everything is a grizzly bear. This one night I was out photographing, and it was probably about 1 a.m., 2 a.m. I was all alone. It was very dark, and I heard the sound off in the bushes, like kind of sound, crunching. It sounded like it was. I was sure it was a grizzly bear, crunching through the leaves in the field just beyond me. Ran back into my car, looked around with the flashlight, couldn't see anything. Got back out. I heard the sound again. I got back in my car, did it a couple times, and then I finally went out and started looking around. I could hear the sound, but I couldn't figure out where it was. Finally, I looked down at my feet, and there was this little salamander crawling around in the dry leaves, making this crunching sound. It was the most terrified I was of anything in the middle of the night, and it turned out to be this tiny little salamander. Other times, when you're driving home from Aurora, you have to be really careful, because there's often going to be some sort of wildlife on the middle of the road. In this case, there's a really bad photo, but this was a llama walking down the middle of the road, probably from some nearby farm, and he wouldn't get out of my headlights. As soon as I tried to move, it would move with my headlights. It probably took me 5 minutes to get around this guy. As jumping on to topic of Steve, as Alan had noted, I do like to photograph Steve. I also like to kind of brag that I have a lot of the worst photos of Steve. You saw a couple of really good Steve photos in Siv's presentation. This is one of my favorite photos of Steve, not because it's a great photo, but because it was the first time I ever saw the thing. And I had no idea what it was. I was out photographing the Aurora. It was about August, and the Aurora, you can see in the left, it had moved off to the north. It was fairly quiet. It wasn't very interesting at that point in time. And I looked up and I saw this line through the sky. I had no idea what it was. At first glance, I thought it was an airplane contrail. It was very dim, very straight. This is, again, at Twisty Road Pond. So northwest of Calgary, this line is going almost directly over Calgary International Airport. It wouldn't be unexpected to see an airplane contrail in that particular path. I turned the camera up, I pointed the camera at it, took a longer exposure, and I could tell, and you could see from the long exposure that the line was actually illuminated. It was putting out light. It wasn't reflecting like a contrail. And that really started off a long exploration of trying to figure out what this phenomena was. That's a much longer story than I think we have time for tonight, but it's a really amazing story. One of the other things that we often get really annoyed about as night sky photographers, Astro and Aurora and otherwise, are clouds. But sometimes when the clouds are just right, they can really, really add to the perspective and the depth of your photo. On this particular evening, this was in July or August, and we had these nice scattered clouds that were getting lit up by the setting sun. This was fairly early in the evening for Aurora photography. It was about 10 o'clock, so the sun had set not too long ago. We were still kind of in a dusk type sky, and it was doing this great job of lighting the clouds up from below with enough gap in the cloud that you could see the Aurora shining through with really vivid colors. The same evening, pointing my camera to the north, we have Aurora high in the sky, and kind of one of your astrophotographer dream shots. You've got lightning in the foreground, striking out of a nice large thunderstorm. It was a very, very active thunderstorm. I've got probably 10 or 12 different lightning shots from this storm with Aurora in the foreground. Such a beautiful night, and not an opportunity that you get very often. A couple of years later, this is the Mother's Day Aurora event, a beautiful Mother's Day present that Aurora gave to all of us. And we had Aurora almost all night long, literally from the moment the sun had set throughout the course of almost the entire evening, directly overhead, over Alberta, and lighting up the sky with blues with greens and purples and reds. These very brilliant curtains of light reaching up into the sky. This is another photograph from the Twisty Road Pond. The same night. This is the night of of Mother's Day Aurora, and you just get this really great sense of depth and perspective as that Aurora is reaching straight up into the sky. This is my first decent photo of Steve. Steve can present in a couple of different ways. You saw a very plain version of Steve in one of my earlier photos tonight. This is a very sporadic, I guess you could call it, version of Steve, where we've got Steve is that very light, very faint mauve colored presentation in the photograph here, and then we've got what we call the picket fence. That's the green in this photo. And this evening, Steve was a very localized. Often it reaches all the way across the sky. In this evening, it was very localized in this sort of narrow band of the sky. This was a photo from last year, March, where we saw Steve again. This was a great night of Steve west. I was east of Calgary, sorry, and there are very different presentations of Steve throughout that evening. We had the mauve arc reaching through the sky, and then it transitioned to these pillars of green and mauve in this very narrow arc reaching across the sky. I was in a horrible location this night. I was just west of Calgary, just north of Strathmore, much too bright of a location to properly photograph Steve. If you had turned my camera around, it would be completely washed out by Calgary's urban glow. I had to do a lot of editing on this photo just to get the balances between the dark and the aurora properly fitted. There's some very faint clouding in these photographs as well, which made it additionally challenging. Urban lights reflecting off a cloud are not very fun. But sometimes we can get very lucky, especially with urban light. So this is obviously the big rock south of Calgary at Okotoks. You've got Calgary's urban lighting in the foreground or in the distance, washing out a lot of the sky. But we also had a very strong aurora that evening. This is the evening that Siv had also photographed Steve with aurora and with the comet Neowise all in the sky, as well as earlier in the evening, there was a very dynamic display of noctilucent clouds along with Neowise. This is one of my favorite photos. This photo is actually painted in the background here by Jay Bigham. Jay is painting on Twitter, and I love his interpretation of what we're seeing with our eyes and how he translates it down onto canvas. One of the other things I really like about this photo is that I wasn't photographing it with a wide angle lens. This was the very first time that I had ever photographed aurora with a telephoto lens. And because I wanted to get the comet nice and large, in addition to having the big rock in the foreground. Not a challenge, not a very easy composition to balance out. I'm going to indulge in a few Milky Way photos. Milky Way is not something I tend to photograph very often, but when I do, I like to. Well, this night I was waiting actually for aurora, and I was photographing the Milky Way as I was waiting for it. What I like about this photo is it looks like we've got sunrise or sunset in combination with the Milky Way, which is not a combination that you would really ever see. In this case, though, it's not actually sunset. That's Calgary glowing in the distance. This was photographed at Didsbury. This was photographed again at that pond east of Didsbury that I like to go visit. And Calgary was really, really bright, and certainly washing out the lower parts of the Milky Way, but still the upper areas of the Milky Way were quite visible. This is the Milky Way from south of Bragg Creek at Forget-Me-Not Pond. One of the things that Milky Way from Alan's favorite location down at southern Alberta. Tricky photo here, trying to get the Milky Way balanced with the city lights, with the township lights in the foreground. That gets very washed out very quickly. What I really like about Milky Way, though, that I started appreciating last summer, was photographing the Milky Way with groups of people. Through the Aurora Chasers community, I started organizing a few different Milky Way group nights, where in the middle of the pandemic, where we could gather in groups outside, nice and safe, and be able to take advantage of those summer nights where we can be somewhat warm. It's still pretty cold in the middle of the night, and even in the summer, but being able to share how to photograph the Milky Way, some night sky photography tips, and just get out and enjoy those skies. it was also nice to photograph some unique opportunities. I like to try to. There's this one tree that is just south of Airdrie. I like to. It's very close to my house. I can get to it in about 5 minutes, and there's a lot of nice visual opportunities to sort of balance it with when we've got the sun and Venus in this case. We're creating this nice composition with the tree in the foreground. And I'm just going to wrap this up with a couple of photos from the November 4th Aurora. What I really liked about that event, like Siv, being able to photograph from within an urban area is a unique opportunity. And November 4th offered that in spades. We had a great opportunity to, my house is in the foreground there. I literally was in my pajamas at this point in time. I had just come home from photographing out in a darker sky location, got home, looked at the data, and realized that we were going to be seeing another round of Aurora, and ran out my pajamas. It took me probably about half an hour before I had the presence of mind to go back in and put on some warmer snow pants. It was not that warm that evening, so it was good to layer up a little bit. And that night just danced forever. We were literally spinning in circles as we were watching the Aurora fill the entire sky. And I think that's my time. So again, thank you for giving me the time to chat. And I'm going to pass it off to Kimberly.
Thank you for inviting me this evening to this presentation. It's quite a privilege to be speaking to all of you this evening. My presentation will focus on my journey, which took me to get to deep space imaging and exoplanet hunting. My current motivation is chasing astronomical events. It's a little bit about what everybody has said before me. This includes conjunctions, lunar and solar events, comets, dark and deep dusty space structures, supernova remnants, and bright and colorful nebula. I follow the RAS calendar closely and hope that the weather cooperates during these times of the month. The Solar Eclipse Chase. This image display, oops, sorry, I went too far. The initial motivation for sharing or starting astrophotography was the 2017 solar eclipse. We bought our first telescope, an 80mm APO refractor, and an entry-level equatorial mount. The desire was to capture the eclipse with a DSLR. We went to the Oregon coast, and luckily the marine cloud layer held off long enough for us to grab a few shots. This one here is an image that displays the corona during the eclipse. The corona is the outermost part of the sun's atmosphere. The corona is usually hidden by the bright light of the sun's surface. During the 2017 eclipse, there were also 3 small prominences that were showing up just along here. The Milky Way Chase. The Milky Way Chase began in Moab the following summer, so this is June of 2018, now armed with a fully modified Canon 5D Mark II. The fully modified or full spectrum conversion refers to the replacement of the internal IR blocking filter in the camera with a clear filter, allowing the camera to capture the entire light spectrum. This allows the camera's sensor to capture ultraviolet, infrared, as well as the visible light. New Mexico the following March in 2019 with the same fully modified Canon 5D Mark II. This is a single exposure from a 5-hour time-lapse sequence. Watching the Milky Way actually vanish into the morning sky was a breathtaking experience. Back to Moab during the summer of 2019. This particular Milky Way image was actually selected for the 2021 RAS calendar, so that was a great honor for me. The foreground in this one was illuminated by the crescent moon, which created the deep shadows that you can see in the foreground. And then once the moon set, the Milky Way and the stars were imaged. This is Grasslands Park in August of 2020. This is part of the luck of always chasing a target. Due to the COVID restrictions the summer of 2020, the canvas cover was removed from the teepee's wooden poles. This makes for a striking composition with the stars right to the horizon. At this point, I'm now imaging with a fully modified Canon EOS R and a filter adapter. This is Red Rock Coulee, just last November, of November 21. A large part of the chase is learning about the sky. Recognizing how the Earth is rotating beneath our feet, the Milky Way appears very differently depending on the location, the date, and the time. Each time I process an image, I research the planets, the stars, and the constellations that might be visible. The Moon Chase. This one was taken along the Icefields Parkway in January of 2021. As part of my progression in this hobby, I moved to doing a lot of infrared work. The long wavelength filters allow for the non-visible IR filters to pass. In this case, this is 830 nanometers and greater. The effects are quite dramatic for many scenes, offering high contrast and details that visible frequencies alone do not reveal. This one was captured at Dinosaur Provincial Park just last week. This one is the 64% waxing gibbous moon rising over the hoodoos. And again, lots of detail and dramatic contrast in these images. The Lunar X and the Lunar V. This one is from March of 2021. The Lunar X, which you can see here, and the Lunar V here, only appear for a few hours before the first quarter, slightly below the lunar terminator line. Dealing with Mother Nature makes this one a challenge to image, as it's only available a couple hours every month. The clair-obscur effect, light and shadow, creates the appearance of this X and this V along the rim of the craters. This is a supermoon from April of 2021, a composite of 9 images, each taken 2 minutes apart. The moon appears to get brighter and brighter as it climbs in the sky. The brightness of any object, including the moon in the sky, increases with its height in the sky. Also, the closer the moon is to the horizon, the more atmosphere the light must travel through to reach the observer. This means that the moon's light is absorbed or scattered by the atmosphere. The partial lunar eclipse. This was November of 2021. The Earth's shadow covered about 90% of the Beaver full moon at 2 in the morning. The shadow blocks the sun's light and stains the moon a dark rusty red. This was actually the longest partial lunar eclipse in the last 580 years, and it lasted for 3 hours and 28 minutes. The Comet Chase. We've seen a lot of comet images tonight, and I'm going to show you a few more. This is Neowise and the noctilucent clouds taken in the northwest sky at about 11 p.m. on July the 10th of 2020. Clouds and the twilight created this beautiful rainbow effect. The noctilucent Comet Neowise and the Big Dipper taken in the northeast sky at about 2:30 in the morning on July the 21st. I was really excited to see the Big Dipper reflecting in the very still pond. The blue ion tail that you can see here from the comet points directly away from the sun and is pushed out by the flowing and charged solar winds. Neowise made its closest approach 2 days later on the 23rd. It was still at 64 million miles away though. One last Neowise image here. This one was captured on July the 17th. At this point I was using an HDR composition here. The images range from 2 seconds to 20 seconds. This allowed greater detail in the dust trail here and in the comet head up here. The Deep Space Chase. This is M20, the Trifid Nebula, imaged from Moab in the summer of 2018. This was one of our earliest successes and deepened the passion for astroimaging. The Carina Nebula. This one was imaged from Tanzania in January of 2019. The challenges were great in Tanzania, not the least of which was polar aligning at 3 degrees south of the equator. A small travel-sized equatorial mount was used with an 80 millimeter refractor. This is an incredible sight. If you think about it, this one is 4 times larger than Orion, which is a common object in our night sky. Alan had a couple of great pictures of the Orion Nebula too earlier on. The next few images are taken with our entry-level equatorial mount and that original 80 millimeter refractor that we had. Here we have progressed though to using a monochrome CMOS cooled camera with narrowband filters. The narrowband filters are hydrogen alpha, oxygen, and sulfur. This image is actually NGC 6888, the Crescent Nebula here, and the surrounding Satyr dust. This one is the Bubble Nebula, the Northern Lagoon up here. the Lobster Claw, and the Dormouse Cluster. These subs were 10 minutes each, and this image is about 5 hours and 50 minutes of data. A wider field of astro images now. These were captured with a small travel mount and a Canon lens, so similar to what Alan had showed in some of his images with the wider field. This was a proof of concept for us, applying the learnings from the entry-level EQ that we had to the travel mount. Subs here ranged from 3 to 5 minutes, and this one is about 3 hours and 40 minutes of total data. It's IC 1805 and 1848, the Heart and the Soul Nebula. This image I fondly refer to as extreme astro. This was taken in January of 2021. The ambient was -22, the moon was 61%, and the gear was completely frosted up. It's a wonder that we got anything out of this image at all. I have to say special thanks to my husband, Laurie, for indulging my crazy idea to set up in the frigid winter conditions in a very remote condition where we have to drag a lot of equipment in. Luckily, he built a fire to keep us warm for the 4 hours that we were outside. Subs here are ranging from 4 minutes to 6 minutes, and this is about 2 hours worth of data. Now we moved into imaging with a more heavy-duty mount and a larger telescope. We're now progressed to 20-minute subs. This one is called Sharpless 2-132, and it's the Lion Nebula. It's located approximately 10,000 light years from Earth. Processing here is using the SHO palette, and it's about 7 hours and 20 minutes worth of data. Narrowband processing using, sorry, wrong slide. This one is the Wizard Nebula, NGC 7380. This is about 6 hours and 20 minutes of data. The Wizard Nebula lies about 7,200 light years from Earth. Then we moved to some upgraded higher quality mounts. The quest here was for better data and fewer discarded bad subs. Clear dark skies are very precious to the Astro Imager, and throwing away data because of mount guiding issues just felt like a waste. Here we're looking at NGC 2174, the Monkey Head Nebula. This one lies about 6,400 light years from Earth. This one was imaged and captured from a backyard in Calgary. Narrowband filters allow for successful imaging in urban centers. IC 405. This one's called the Flaming Star Nebula. It's about 11 hours worth of data. This one's approximately 1,500 light years from Earth, so relatively close in comparison to the previous couple of images. This is a single 20-minute exposure as it comes out of the camera with no processing of any kind. There is a misconception of Hubble quality images directly from the camera. These images take as long to process as they do to capture. I spend many hours in front of the computer getting the final product exactly as I see it. All these structures are real. The processing reveals what is or is not emphasized. Processing is very much an art, and everybody will add their personal artistic vision to the target. This is the full color processed image. NGC 281, the Pac-Man Nebula. This one's about 15 hours worth of data, and it's approximately 9,500 light years from Earth. Again, this one was captured from a Bortle 8 sky condition, urban backyard. This one was taken with another higher quality, smaller weightless mount and an upgraded refractor scope. We now have the ability with our small refractor to guide successfully at 20-minute subs. This one is IC 1848, the Soul Nebula. And here we're looking at about 20 hours and 30 minutes of data. This one's approximately 6,000 light years from Earth. Distant supernova remnants are generally very faint. Capturing this target from a dark sky site also allowed for the faint detail to be imaged. Here we increased the sub duration to 30 minutes. Capturing LRGB images from an urban setting is almost impossible. This is called CTB1, and it's approximately 10,000 light years from Earth. Chasing the dark structures. This one's called LDN 673, and it's a very dense and highly fractured dark cloud complex. It's located about 400 to 500 light years from Earth. This is another example of LRGB imaging from a dark sky site. Barnard 150, it's called the Seahorse, or LDN 1082. This is a dark molecular cloud of dust. The cloud is part of our Milky Way galaxy and lies about 1,200 light years from Earth. By rotating the image by 90 degrees counterclockwise, you can make out the distinctive seahorse shape. This one is a science versus art debate. One feeds the other in terms of motivation and perspective. Here is an LRGB image done from a dark sky site. It shows a so-called Herbrig-Haro object, which was discovered in 1977, an ionized gas jet emanating from the pole of the newly formed star in a stellar galaxy. This image was taken to satisfy art, but reveals much more. The exoplanet hunt. Exoplanet transit detection and measurement requires determining the brightness changes over time of a large planet, Jupiter size or so, as it crosses in front of a star, our sun plus or minus in size. This requires multiple exposures, each of sufficient length to allow photons to be captured and counted by the digital camera, essentially measuring the change in brightness over time. These kinds of measurements are quite new, and the first one was only done in the mid-1990s. The advancement of digital cameras and other equipment allows us to take part in this effort of adding data about these. The blue graph at the top represents the change in brightness as the planet crosses in front of the star. The pinkish and reddish graphs below represent the constant brightness of check stars or control stars. All the demands that good imaging makes of us sets us up for exoplanet work really well. All of the tools and techniques that we use are employed with exoplanet work. When we started this, we didn't know if the photometry measurements and analysis would work, but we knew we could image a star over a long period of time. If anyone's interested in exoplanet hunting, please check out Laurie's Sky News YouTube video. It'll be on the last slide, and we can have Brian also put it up in the chat if anyone's interested. This is just a quick shot here of our Astro camping crew. It's a very skilled and enthusiastic bunch. There are many talented people in this group that want to share their knowledge and their expertise. And I can't take all the credit for the beautiful images that you've seen tonight. I also have to thank my husband, who works tirelessly to set up and run our imaging equipment. Without his persistence and dedication to details, my chase would have ended with the Milky Way. Thank you for the opportunity to present, and I'll hand this back to Simon now.
Great, thank you, everybody. I'm speechless, honestly, with all of that great work that we've seen here tonight. We do have time for Q&A. I know a lot of you have put some questions into the Q&A, so I would invite all the speakers tonight to turn on your cameras, and we'll have an open discussion on some of these great questions. The first one that comes up, that came up quite a lot, Chris, I might turn this one over to you, but what exactly is Steve?
That's a fun question. It's a tricky one to answer in a short period of time, but Steve is a Aurora phenomenon. Well, it's a phenomena that is associated with Aurora, but is definitely not what we typically consider to be traditional Aurora in the traditional sense. Steve is something that's been observed for a long time. It's something that has likely been in our skies for hundreds of years. But Steve is it's quite dim, which means that it's typically easier to see when you've got some long exposure imaging equipment, such as a DSLR camera. With the naked eye, it's often easy to mistake for cloud. It is something that we started observing in the Aurora Chasers community, that we started taking photos of in the 2014 to, well, up until now. The interesting thing about the story is that we started originally calling it a proton arc. And when we first encountered some of the scientists who have been studying studying the Aurora for a long time, they let us know that a proton arc is something quite different from what we had been observing in the sky. But they weren't familiar with what it was. It was something that was completely new to the Aurora researchers. So they asked us to help them figure out what it was. And they also challenged us to give it a name other than proton arc, because that was completely inaccurate. I'm not a very creative person, and so I brought it to the Aurora Chaser community to talk about, what should we name this as a temporary placeholder name. As a conversation starter, I suggested we call it Steve, and that prompted a lot of conversation. And ultimately, at the end of the day, we ended up calling it Steve in the community. And then when the story went viral a year later, and news networks around the planet were talking about this crazy group in Alberta calling Aurora Steve, the name kind of ended up sticking, and it has since been backronymed to the scientific term strong thermal emission velocity enhancement, or Steve for short. Long story short, Steve is something that is an area of quite a bit of ongoing study, and there are many research groups around the planet that are studying it, trying to figure out what it is. They're still not completely certain what exactly is causing Steve. They know what it's associated with. They're getting a lot closer, but a lot of its causes are still unknown. I think that's a short-winded attempt at a long-winded answer.
Oh, that's great. Thank you for that. I know a lot of people were asking about Steve, so thanks, Chris.
Yep.
Here's a question. As a newbie that has zero experience and looking at this as a new hobby, how does one get started? Siv mentioned sleeping for a few hours before going to work. What does the life of a night sky photographer look like? And are there folks that will guide a complete new person in the process, i.e. borrow their tools?
For me, pretty much I gonna be like shooting sometime like up the sunset until sunrise. If the sky is clear and the aurora is still there, I will shoot until my batteries die. Then I will go home. If my battery is still there, I will keep going until sometimes I just have to drive to my work and sleep right in front of my work, and then wake up and just go straight to work without driving back home. Yeah, sometimes in the south, my work in the south, I live in the north, so it's not lucky like Alan have a backyard that he can take picture with. So, so sometimes it's just like wherever I go, I sleep there, and then wake up, keep going on my road trip. The same thing. Maybe I would do like couple night road trip. I just go wherever I can find clear sky and stop there and shoot it and sleep and wake up, keep going. If it's cloudy, keep driving. And if it's clear, just stop. And wherever I go, just watching for the cloud, I guess, to decide where I go in next. Sometimes I don't even know myself where I'm gonna go. But wherever have clear sky, I think that's the most important, I guess.
Well, you do have to keep in mind that the people you've seen present tonight, I guess myself included, we're passionate about this, right? I mean, we're crazy about this. And someone was asking about, what inspires you to get into it? And everybody would have a different answer, but it's, we will go to great lengths, and you don't have to necessarily go to the ends of the earth and give up your sleep and whatever. You can get some pretty nice pictures with the equipment you already have. But it's getting to know the sky and taking advantage of the clear skies, and even just getting out of the city a little bit. There's stuff you can do in the city, as you saw with Siv and Chris's with the Aurora comes along in twilights and things like that. There's and the moon and conjunctions. There's lots you can do with quite simple equipment that you already have, and it doesn't require staying up all night long. And just get used to using your camera and focusing it, because focusing manually is typically what you got to do with most of these, and you're not used to doing that with your daytime shots, and taking longer exposures, and just start simply and as soon as you start to see some results come up on the screen, and that's the beautiful thing about digital images. Again, someone was asking about what inspired you to get into it. I've been in this hobby since the days of Tri-X film and Plus X and high-speed Ektachrome, and you didn't know what you got until days or weeks later. But with digital, you see the results right away. And when you see the Milky Way or the Aurora colors or whatever it is come up on the screen, even in a short 20 or 30 second exposure, showing you more than your eye could see, you're hooked. And you want to shoot and see more. And that's the beautiful thing, is that the results are immediate. Of course, you improve and improve and improve your craft. We're always doing that. Everyone. And that's the other attraction, is that there's new equipment, but new techniques and new software and new things that are always allowing us to improve our craft all the time with photography, and staying on top of that's part of the fun. And part of the challenge of it. I just discovered some new Photoshop actions that suddenly, whoa, it just makes such a great difference to your pictures, and and things like that, or new equipment. And today's cameras, they're all great. When you're talking about, Canon, Nikon, Sony, whatever it is, they're all great. Camera equipment today is just amazing. So it doesn't really matter what brand you buy. You can get great shots with anything now. I mean, a good quality camera.
There's definitely a slippery slope of budget when it comes to camera equipment. You can spend a lot of money very quickly and easily. But it is nice to focus on, I think, what you can do with a fairly inexpensive camera. What a lot of the phones are doing now. This year's crop of Samsung and Apple phones, I've seen some amazing photos of the Aurora captured with a cell phone. It's really stunning.
Definitely. And yeah, about the equipment, just like to remind everybody that the RASC will be starting a camera for rent program where you can get your hands on some great equipment and try out some of these things. There is a steep learning curve, but also there's some opportunities for some easy wins with the right mentorship, and we hope to provide that for you. So look out for that in the coming weeks and months throughout the summer. I'd like to move on to another question for Kimberly. With your deep sky images, people are curious what type of equipment that you use to take those. And you mentioned going from kind of easy to more advanced. So I'm just curious about that journey.
That's going to kind of look at what Chris was just saying about the slippery slope. So we did start out with some very inexpensive beginner entry-level equipment, a Celestron AVX mount and a 80 millimeter refractor telescope, probably $2,500, $2,600 all in, just a camera that I had already. And yeah, and then you progress through it and you want more and more and more and better, and you just get hooked. You start seeing those images come up on the screen, and you can see what you can see in 2 minutes, and I want to know what it looks like in 5 minutes. And then, we've progressed to those 30-minute subs, and you sit there in front of the computer and you wait, and then that supernova remnant comes up and you're high-fiving, and it's just the adrenaline rush. So it really depends what you're chasing. You can start out for very cheap, and then once you get hooked, it's a slippery slope and you're going to spend a lot of money.
Thanks, Kimberly. Moving on to another question. Why did you all decide to turn your cameras towards the sky? What inspired you to do that? And let's go in the order of speakers. So starting with Alan.
Well, as I kind of mentioned, I've been doing this since I was a kid with film and my dad's camera and the like. And it's just an interesting aspect of the hobby. You see these things in the sky, and it's nice to be able to record them and to not document, but just to capture the moment, like as you do. Why reason you take pictures anyway for anything, just to remember the moment. But it's also a technical challenge because, as you gather, there's quite a bit of technical aspect to to learn, and that's part of the challenge and part of the fun and the satisfaction is learning that. And so and I've been in and out of the photography hobby over the decades because it gets so advanced, it's beyond me, and I don't want to go that way. But it's just something always new emerges. Oh, I want to get into that and try that, but I'll only go so far in the very technical aspects of astrophotography. I kind of say, no, that's my limit. I bought enough equipment. I don't need to go that route to buy this whole new batch of equipment. But it's the satisfaction, as I said, of digital, where you just get great results relatively easily and immediately, and you get hooked on that. And so that's my attraction.
Great. How about you, Siv?
So for me, like it's been told earlier, is the media shower. It's when I started at 2014. I took all my family to a field like 45 minutes from Calgary, like north of Calgary, just near Old, I guess. So we've been watching like the media shower from like Germany media shower on December. It's pretty warm night, like +5 on December. And we're watching it from like 10 o'clock until 2 o'clock. That's my family. Just that is so weird to watch that, but it's make us like keep awake the whole night because like the media on that year is insane. Like you can see like 2 or 3 at the same at every second, and been the whole night. Like for 1 hour, we might see more than 100 that night. That is the best one, like clear night and everything like so cool. And that time I only have like a Nikon 1AW1, something like that. I can't remember, like the first mirrorless. And I just try to capture it, but I don't know anything about the manual shoot yet. And then I try it with my brother and we try to do manual and try to do ISO stuff like that. And my first picture of the star that I can see to make like it's so bright at night, that is make me wow about that, and start to come home and then try to figure out how to shooting in the dark. That's where that time I already joined the Alberta Aurora Chase group, and they did like have a lot of amazing photo with the Aurora stuff like that. So I've been watching people picture and sharing their picture and start saying like, wow, when can I do stuff like this? Like I've been followed that I've been like almost a year until I figure out like, oh, let's just buy a camera and then try to shoot like whatever you guys mentioned on the setting and just follow that. Watch a couple YouTube, like one of Alan Dyer. He have a tutorial on YouTube. So it's been so easy, that one. So I just follow that and then try to go out and try to capture it and practice and practice. Whenever I have clear sky, I just go out and it just hooked me up. Like every single thing, like the more you go, the more you get better. And I finally find out that from my house, just like 5 minutes east of Calgary Airport, I can see Aurora from my window that I've been doing for 10 years. I never know about that. And I always talking on the Facebook, when can I see this? Actually, it was there, but you never know that. So after I found out that, oh, Aurora is not far from me at all. So that's how I hook up, go buy a camera and start from one full frame camera that I started is the Nikon D750 with the Nikon 1424 and a 50 millimeter. That's how I started that one. And after that, I just start doing the Aurora and the Milky Way. And at the time that you can see the whole wide angle couldn't fill up. So I started thinking of second camera and third camera, and now I have 4. So I do like 4 cameras for my media shower, just facing it everywhere, even with my fisheye, try to capture all those media. So it's the shooting star or the fireball. It's not easy, but it's more like about luckies. It's not just like how you can do it, right? It's more about luck. Sometimes it's just like when you change your battery, the big one just shooting. So just that's how I hook up with this thing. And it sounds like something addicted.
Definitely, I definitely agree with that. Chris, would you like to chime in?
Yeah, I mean, I call myself a chaser of elusive things. And it's because Aurora, and I mean, so many things that the sky does. There are elements of behaviors in the sky that you can predict, but you can also get it wrong. So there's this challenge, right? There's this, it's like a game of cat and mouse, but it's attainable. And you can say, well, I think there's going to be Aurora tomorrow night. And maybe there's like a 30% chance of it happening. And when you get it right, there's like that reward feeling of knowing that you nailed it, knowing that you got the prediction right. And in Alberta, in southern Alberta, well, in all these latitudes, it's really important that you know when to go out and see the aurora, because, like as Siv noted, you can see it from your house, but if you're not looking, you're not going to see it. And you really got to know when to go out and look for it. So it's that game of knowing when to get up, knowing when to go running out and get warm and go see the amazing things that the sky does. Alan's name on Twitter, Alan's website, Amazing Sky Guy, right? Like that's really quite sums it up, right? The sky is amazing, and it's really a big treat when you can see what it's doing.
For me, it started with landscape photography. I've been doing that as long as I can remember, from being just a little girl with film, just like Alan was talking about. But I think for us, it was the progression. So it was the 2017 solar eclipse that got us hooked on actually buying equatorial mounts, getting our first telescope, and just completely getting hooked on it and being passionate about this. The learning curve that you have going through the different DSLR cameras, progressing through the cooled astrophotography cameras, incorporating bigger and better mounts, and the learning curve. The community around it, everybody is so willing to help, and everybody wants everyone to succeed. We all come at it from a different direction. So it's truly the enthusiasm and the passion. And then for me specifically and personally, it's just the ability to do something that's a hobby with your spouse. So Lori and I love doing this together, and I think that really helps if you've got a passion that you're both driven by, and you can do things together. It's just a wonderful thing. Sitting up in the middle of the night, you know there's always somebody beside you. And if we're out astro camping, there's 20 people sitting around us all doing the same thing and all high-fiving as those first subs start coming up. So, digital photography has definitely changed this, and the instant gratification is there for everybody.
Kimberly, I'm gonna throw another question in your direction that's been asked a few times. You mentioned about a lot of processing to develop a final picture. You mentioned hours and hours of processing, and I know how much effort you put into that. Do you have like a very high level idea of what's involved in that in the processing, and what types of software that you use for it?
Absolutely. Yeah, that's a great question. As far as the processing, we capture all the images. Generally, we're doing the monochrome narrowband imaging. So there's the 3 sets of filters that we're using: the hydrogen alpha, the sulfur, and the oxygen. So the processing is done through PixInsight, which there's a huge learning curve on PixInsight. It probably took me a year to actually get up and running and figure it out. And now I'm at the point where I can use it the way I could use Photoshop. So basically you're taking those 3 different bands of light, you're stacking them on top of each other. So let's say I have 15 different H alpha subs. Those all need to get stacked together. You stack all of the sulfur, you stack all of the oxygen. Then you have to combine those 3 different bands together to get it into one image. It's just a whole long processing curve. There's the beginning of putting it together. Then there's the stretching of it. Then they're starting to apply the art to it. How do I get the details out? How do I extract what I want to really see? What color palette do I put to it? Where do I put the lights? Where do I put the darks? Do I bring out this dust? Do I not bring out that? I did a Pleiades one not that long ago. Not one of my best images, but it was just something as more of a proof of concept. And I put it on Facebook, and I had a couple people come back and go, why do you have all that dust in there? Did you do something wrong? And I thought, well, I spent hours and hours trying to extract that dust and show you the dust. And then I get somebody saying, well, that's ugly, put that back. So it's all artistic and it's all personal preference. But, if we spend 20 hours getting data, that CTB one was 20 hours worth of data, I probably spent 10 or 11 hours actually processing that on the computer just to get that one image.
Wow, that's absolutely amazing. Here's kind of a technical question. I know there are a few shots of Waterton amongst all of you. Somebody lives in Waterton, and they've really struggled with how bright the town is. How do you get a shot without the town being insanely bright and taking over the picture?
Well, Chris had a shot very similar, because this is your classic Waterton shot here, taken from in front of the Prince of Wales Hotel. And this is a blend of long and short exposures. So long exposure for the sky in the foreground, and then a short exposure, maybe only a second or two long, for the town, and that's blended in and masked in Photoshop. So otherwise the town would. And Waterton has done a wonderful job of reducing lighting, shielded lighting, low temperature lighting, all the right kind of LED lighting, dark sky friendly lighting. But when you're doing a 20 or 30 or 40 second exposure, or might have been a tracked minute or two for the background, it still blows out. So this is a blend of short and long exposures blended in Photoshop, kind of like what Chris said, HDR, high dynamic range, where you or Kimberly said that with a Comet, where you take a bunch of short and long exposures, so you get the best of both all worlds kind of thing. What shows up best in a short exposure is captured by those, and then the faint stuff captured by the long exposures, blended together in Photoshop in this case.
Great, thanks, Alan. Another technical question along kind of a similar vein is, somebody's curious about the method used to keep the rocks in focus with the sky objects also being in focus, and what sort of method goes into doing that.
I think in some ways it's a similar answer to what Alan just said. There's a technique called focus stacking, where you're taking your distance shot with your long distance focus and your near shot with a much closer range focus, and then you're blending those different photos together to get that uninterrupted degree of focus. Or you do what I do, and you just get a little bit far enough away from your foreground rock, and you have your focus at infinity, and you're going to get both in focus. Your near ground rock isn't quite going to be as good, but if you keep things small, it's less noticeable. So you cheat. But some photographers, like Paul Zizka, is really well known for his foreground and background being in really solid pinpoint focus.
Oh, that's great. Thanks for that answer. The question is, assume somebody doesn't have really fancy equipment, or they maybe just have a consumer level DSLR or just simply a phone device. How can a person like that get into astrophotography with just the kind of the simple tools such as those mentioned?
Just put those cameras on a tripod, just hold it nice and steady, and open the shutter for 10, 20, 30 seconds, depends on what you're shooting. A little bright conjunction of the moon and planet, it's only a couple of seconds, almost handheld, but with today's cameras. But just put it on a solid tripod. If it's a phone, there's clamps you can buy that would put it on a camera. And I know with my iPhone, once it's steady, it then senses that and allows you to go up to 30 seconds. So it depends on your camera. The Samsung and Huawei phone cameras are amazing, as Chris said. And so if you got those, just go into their night modes. You don't even need a special app, just whatever is included with the camera, go into the night mode and just play with that. Just have fun and play with it, and go at it with that, or whatever camera you have. A fast wide angle lens is generally kind of the key secret, but just put it on a good solid tripod and start firing away, and just note your settings and learn. That's how you get started.
Great. And along the same theme, somebody asks about the Aurora. What sort of beginner budget equipment can you use to get some great Aurora images?
Again, the phone that you have. If it's a last couple of years phone, it'll do the job. It really will, but hold it steady. So that'll do the job, or any camera that you have. But the fast wide angle lens is kind of the key. The kit zooms and things will work if it's a bright aurora, but a slow f5.6 lens, you're kind of struggling with auroras and Milky Way with the slow lenses. So the fast, and you don't have to spend a lot of money. Like there's a 14 millimeter 2.8 Rokinon lens that's very popular, and it's $300 or something for DSLRs and mirrorless cameras. And that's a very popular lens to get started with for nightscapes.
Okay, no, thanks for that input. The question people are asking about tracking mounts. Does it help for Milky Way pictures and Aurora pictures? What are kind of the pros and cons of having a tracking mount?
I was going to say a tracking mount, if we're talking about Milky Way, helps quite a bit. You can take your subs from maybe a 15 or a 20-second exposure, and you can go up to 2, 3, 4 minutes. So being able to track, you can drop your ISO, you reduce your noise, you get a much better quality image right out of the camera, less processing is involved. If you're on a tripod, you can probably take 15 or 20-second exposures, but then you want to take maybe 10 or 12 or 15 of those and stack them all on one another to get rid of that noise. So the tracking mount definitely helps for Milky Way. I don't think it would make a difference on Aurora though. Now, Chris, I'll put that one over to you.
Yeah, no, not really. Tracking doesn't really bring too much to the Aurora game. Aurora, we're typically taking, you actually want your exposures as short as possible with Aurora, because then you get the nice vertical definitions that the Aurora curtain offers. With long exposures, you end up getting a blur of green throughout your entire photo. So we're trying to get our exposures as short as possible, which means we do tend to drive up our ISO when the camera can handle it, or we're also aiming towards those faster lenses, f2.8 or faster. But if you're taking a photo with a camera kit lens, you can typically capture the Aurora in a decent photo with the kit lens at about a 20 to 30 second exposure. You're going to get some blurring in the Aurora, but you won't. It'll still be quite usable.
I just would like to thank all of our speakers here this evening. It was such a wonderful, wonderful night to see all of your great images, and I understand all the hard work that goes into that, and thank you so much for sharing that with us this evening. Just want to ask if any of you have any final comments before we close off for the evening.
I'll just put one more plug in for the Astroimaging certificate. If anybody's interested in that, please have a look. You probably have images that already qualify.
Great.
And there was questions about, when do I know if the Aurora's out? Follow the Alberta Aurora Chasers Facebook group, Chris's group, and we're all members of that. That's your best bet, especially here in Alberta. For when it's going to be. Is it out tonight? The pictures will be posted almost immediately that people are taking. This is what I'm seeing now from, whatever. And so that's your best bet if you want to know when to go out. And is it good tonight? Is it out? Or, follow the Alberta Aurora Chasers Facebook group for keeping up on Aurora visibility.
Awesome. Well, thanks again for joining us here this evening with your wonderful images and pictures. I just want to close out by mentioning our next month's lecture on March the 17th on ALMA, the radio universe, and Dr. Brenda Matthews, one of the lead scientists who works for ALMA, will be joining us to give a presentation on how this observatory is used to analyze comets, black holes, exoplanetary formation, and a variety of other great astronomical means. So I'd just like to close us off by thanking all of you for joining. And if you have any questions about the Royal Astronomical Society of Canada, you can, I'll bring up our slide again. You can contact us at one of these various social media outlets, or email, or website, and we'd be happy to answer any of your questions.